Hello. MESOC Serapeum is a project that enables MESOC consortium members and other cultural stakeholders to become acquainted with the achievements of artificial intelligence and gain insight into the possibilities of artificial intelligence through analysis of scientific papers about societal values and impacts of culture and cultural policies and practices. Project used transformers, state-of-the-art deep learning models used in natural language processing project tasks, and here we use it for language translation, question answering, summarization, semantic search, and text classification. MESOC Serapeum projects consist of following parts: search, analysis, transition variables, indicators, taxonomy, and tools. Currently, there are 578 documents in the database with more than 300,000 sentences. And there is a classic search on the articles, but in order to search for cultural artifacts, literal matches of query words is not sufficient, and therefore semantic search is used. Semantic search is a technique that uses machine learning algorithms to understand the content, intent, and meaning behind the user's query, rather than relying solely on keyword matching. In Serapeum, semantic search is implemented for search of similar articles, search on paper abstracts, full text search, single paper search, and search on transition variables. Let's try the document semantic search. We put here what is impact of music, and we click on search, and we get 10 articles which are connected with our query. Note that the paper number 766, Exploring Well-being and Creativity through Collaborative Position as part of HAL 2070 City of Culture, doesn't have music in the title, but if we look at the paper, we will see that in the first sentence of the abstract there is a group music making suggestion. In the analysis part, we start with particular document analysis. So for each article, there is not only description and abstract, but there is also article analysis. So we click here, and we see that for each article, deep learning models are used to find keywords, transition variables, summary, then to find category of article, find social impact of article, see word cloud from article, create article semantic search, find semantically similar articles, and at the end, knowledge graph for article. For example, we can see transition variables of the article, and if you see here, there is a conclusion, there is a reliable evidence for positive effects of music on singing and well-being in adults. Then we can get the summary, which is not the abstract, This is a summary of the sentences from the full article. Then we can find social impact of article. We see that these articles is 99.8% on health and well-being. Then we can see word cloud with the words which represent the article. Then there is also semantically similar articles, so we can see which articles are semantically similar. And at the end there is also a knowledge graph for the article, and you can see the artifacts and connections between them. There is also a document map, presentation of the geographical area that articles is about, and you can see, for example, what articles are connected with Ireland, for example. There is also document, topic and cluster analysis. First we see cluster analysis. That is statistic analysis of articles, and the text clustering involves grouping text based on their similarity in terms of content, language and context using statistical algorithms. And here you can see each document with its cluster and how the documents are near one to each other. This is for cluster analysis. And then we have also the topic analysis. Involves identifying and underlying themes or concepts discussed in meso collection of text. A topic model concedes exploring a set of documents and discovering, based on the statistics of the word for each document, what the topics might be and what each document's topic is. And we can see the topic analysis. You can see here the topics, for example, and the clusters. And if I click on art, you will see that the art is mainly in cluster number 5. In cluster number 1 is research, but it's not only the research, and so on. Next we present transition variables that are contextual elements which can be measured, ensuring that the cultural policy or practice under inspection is generating public value and or affecting at least to some extent the target individuals or groups. And we are extracting these data from the documents. And we are doing it using BERT, bidirectional encoder representation from transformers model, as a text classification tasks. And then we are fine-tuning it with our sample of 3,500 sentences, each on which is manually marked as transition variable or anything else. And we get these transition variables. For example, for health and well-being, we have most participants expressed improved well-being after the intervention, such as improved mood, calmed anxiety, and or a feeling of enhanced confidence. And you can see from which article this is taken. Subsequently, from documents, MESOC taxonomy is created. The MESOC taxonomy is not simple vocabulary, it's rather unique knowledge base. Through rich metadata of links, the MESOC taxonomy provides powerful tools for knowledge creation, complex research, and structural model of the societal dimension of culture. And then we go to the MESOC taxonomy. We see all the data here, and from that we can go to the MESOC taxonomy graph, where not only the nodes are presented but also the links between them. So if we click here on singing, we will see that the singing, it has a description here, Wikidata reference, semantic view, art and architecture reference. Then we see that it is the superclass of choral singing. This is the subclass of performing arts, and we can see that singing reduced anxiety, singing improves emotional well-being, and so on. And here are the documents which where this is written. At the end, social impacts as the term which describes the changes in the quality of life, health and well-being of the persons have been generated. For this, we are using Dialog GPT, that is the engine that is used for Chat GPT, and we have impacts of culture, MESOC-defined impacts, and policy measures. Let's see MESOC-defined impacts. For example, let's go on advertising and its impacts on health and well-being. We see that it encourages unhealthy behaviors. Advertising can encourage unhealthy behaviors by promoting products that are harmful to health, such as tobacco products, junk food, and alcohol. And we have all here 10 impacts. Then we can go back and see the policy measures. For example, let's see the policy measures that could increase the impact of culture to health. First is develop community art programs, then encourage arts-based therapies, encourage cultural exchange, and so on. Thank you.